Hi, my name's Jared.
I'm Elise.
I'm Michael.
And we're doing measurement.
Tell time to the quarter hour using the language of past and to. To do this activity, all you need is a paper plate, some coloured pens, a ruler, some fasteners, and a pair of scissors. A paper plate works well for this activity because each groove in the plate can be seen as 1 minute, but still allow us to have a bigger section for our o'clock, quarter past, half past, and quarter to, as these are the ones we want to focus on. To start this activity, we will write the hours 12, 3, 6, and 9, making sure to use 4 grooves for each, so they are focused on by the students. As there is 15 minutes between each of these hours, we are able to leave 15 grooves for each. When this is finished, students are able to draw a line down the middle and write past the hour on the right and to the hour on the left. After this, students may write in each 5 minutes and if it is past or to the hour. For this, students need to be aware that when they get to 15 minutes, it is called quarter past, and when they get to 30 minutes, it is half past, and at 45 minutes, it is quarter to. Students also need to be aware that when it gets to 12, it is neither past or to, it is o'clock. They also need to be aware that when they get to half past, it then goes from 30 backwards instead of from 0 to 30. Students will now need to cut out their hands for their clock and stick them on with a fastener. Teachers may like to hand out their own hands so students don't draw them too big or too small. Students will then need to put a hole in each end of their clock hand. And also a hole in the middle of their clock. Then they will need to put the fastener through each hand and then through the clock. This makes it able to move both the clock hands around for the teacher to make different times. Tell time to the minute and investigate the relationship between units of time. 60 minutes is an hour and 60 seconds is a minute. A paper plate also works well with this activity because we can again use the grooves to represent a minute or a second. To make it easier for students, we will again use 4 grooves for the hours 12, 3, 6 and 9. This will leave us with the right amount of grooves to show 60 seconds in a minute and 60 minutes in an hour. We will start by writing the hours 12, 3, 6 and 9. Remember to use 4 grooves for each. Next, we will write the numbers 1 to 60 in each groove. Remember, in the sections with 4 grooves, we still only want one number. When this is done, we can write 60 seconds equals a minute and 60 minutes equals an hour at the top. Also write seconds and minutes in our section with 4 grooves just to remind students. Then we can cut out our hands again and stick them on with a fastener. Students may also like to write 60 seconds in a minute and 60 minutes in an hour larger on their clock. This will show students that there is 60 minutes in an hour, but also 60 seconds in a minute. A misconception many students may have is believing that there is 100 seconds in a minute and 100 minutes in an hour. This may be caused by previous use of our base 10 materials. Teachers can overcome this by hanging their clocks around the room for them to see.
Level 4. Use scaled instruments to measure and compare lengths, masses, capacities, and temperature. Level 5. Choose appropriate units of measurement for length, area, volume, capacity, and mass. Level 6. Convert between common metric units of length, mass, and capacity. This activity allows students to measure both themselves and other classmates. Using wool, measure the length of the student, making sure that the wool goes from the top of their head to the bottom of their feet. Now making sure that the wool is touching the ground, and now I'm measuring from the top of their head across to here. Now I'll cut the wool to size. Now I'm going to measure the piece of string with this 30cm ruler. This 30cm ruler shows the centimetres up the top, as well as the millimetres on the other side, or 300 millimetres. I'm going to use a method called iteration, which is using the same scaled piece of measurement and just replacing it as I go along. So 30 centimetres, 60 centimetres, 90 centimetres, 120 centimetres, 150 centimetres, and then it's 159 centimetres. That's how tall Elise is. Now simply just switching the ruler around, so now the millimetres is showing on the left. That's how much we're going, that's what we're going to measure in. So now I know 30 centimetres is equal to 300 millimetres, 600 millimetres, 900 millimetres, 1,200 millimetres, 1,500 millimetres, and then 1,590 millimetres. So now we've measured Elise in both centimetres and millimetres. And that is an easy way to show the conversion between centimetres and millimetres, and it's also a good way of showing comparisons between the two. One misconception students may have with this activity is believing that this 30 centimetre ruler is actually 1 whole metre, because it is one whole ruler. Another misconception students may have is that you can't compare millimetres and centimetres, or centimetres and metres, or millimetres and metres. To get around this, you can use this 30 centimetre ruler again and show them that up the top there is 300 millimetres, and down the bottom, the same side, 30 centimetres, and that they are both equal. That shows that the comparison is possible.
Calculate the perimeter in the area of rectangles using familiar metric units. What is perimeter? The perimeter of an object is the outside border around an area. For example, we have a rectangle. The outside of the rectangle added together gives us the perimeter. To do this, simply add 6 plus 6 plus 10 plus 10. Together gives us 32 centimetres. We can do this easily because all of the sides are measured in the same metric units, in centimetres. If we simply put a string around all 4 sides of the rectangle and then took the string and put it straight, then we would have 32 centimetres of string. What is area? Area is talking about the inside of an object as opposed to the outside of an object. The area of a rectangle, or any shape, would be the space inside the shape, shown here in blue. To find the area of an object, we simply multiply the width by the length, as shown here, 10 centimetres and 6 centimetres. 6 times 10 gives us 60 centimetres. Because we're using 2 dimensions, we must put a 2 in the top.
Once the concepts of area and perimeter have been developed, certain activities or investigations can be undertaken. For example, this activity involves students developing their own floor plan. Each student is able to design and develop and become imaginative. For instance, this student has come up with a floor plan or room based on a cafe, and this student has built a mini playground. Once their floor plan has been developed, they can then go away and then work out the area and the perimeter of each of their floor plans. This activity is great so that students can put their newfound knowledge into action. So, for example, this student has gone away and found that one side is 12 centimetres and the other side is 13 centimetres, corresponding sides, and then gone and used his knowledge of area equals length times width times 12 by 13, finding 156 centimetres squared. He's also gone away and found the perimeter by adding all four sides together. This activity here also shows that if an area of an object is the same, for example we have 156 centimetres squared, 156 centimetres squared, we can also have different perimeters even though the area is the same. Some common misconceptions with area and perimeter are confusion between the two. Students may also confuse the fact that perimeter is the addition of all four sides, whereas area is the multiplication of length by width. This classroom display clearly shows the difference between the two concepts. It also clearly shows that area is the space within an object and perimeter is the outside of an object.
Thanks for watching our video.